Hi friends, welcome to another video on control systems. So in this video we'll see some problems on time responsive systems. Okay, if you know these things, it would be easy to understand the topics of this particular video. So these minimum things. Okay, this is obviously required. Okay, let us proceed with this and then now let us consider this particular problem. So there's a servo motor. So having it's a CFD, that is time response of the system is given by by 1 plus 0.2 e power minus 60t minus 1.2 e power minus 10t. So this is the time response of a particular servo mechanism for a step input. So we are asked to obtain the expression for the closed loop transfer function. That is, we are supposed to find what is CFS by RFS, and we are asked to determine the undamped natural frequency and damping ratio of the system. So in the B part, we are supposed to find what is omega n and zeta. Okay, let me just go to the problem. This is what we have. So these are time response provided R of t is a unit step input, and we are asked to find what is CFS by RFS and what is natural frequency and the damping ratio, that is zeta. We know that uh, so this is CFT. This is CFT. Uh, of course, so if you want to know what is CFS by RFS, so uh, I should be finding what is CFS. So and with R of t as this, so if you find the Laplace of this happens to be 1 over s, meaning I have the Laplace of the unit step input as 1 over s, and let us find what is CFS of this. So what is CFS? It is nothing but Laplace of CFT. Laplace of CFT is CFS. So what is CFT? CFT is given by this. So I have to find the Laplace of 1 plus 0.2 e power minus 60t minus 1.2 e power minus 10t. So I had to find the Laplace of this particular equation. So I know the Laplace of 1 is 1 by s. I know the Laplace of e power minus at. So we know that Laplace of e power minus at is nothing but 1 over s plus a. 1 over s plus a. So what I have now is this one. So I can write it as 0.2. This is since it is e power minus 60t, I can now in place of a you have 60, so this is plus 60 you have. So this is what is the Laplace of this particular time, and here it is minus 1.2 and it is s plus 10, s plus 10. So this is my CFS, this is my CFS. So then what is so this is CFS. So what I do is, so we are supposed to find what is okay, let me just do this. Okay, CFS uh, by RFS. So CFS by RFS. So what is RFS here? So okay, let me just, so this is now CFT is this. Uh, let me find what is uh, let me take the what LCM of this. Will it not be S into s plus 60 and s plus 10, and is it not s plus 60 s plus 10 plus s into s plus 10 minus s into s plus 60. This is what is the value. So this is, so upon simplifying, so now what is this you have? So you have this as CFS is equal to, so now it is S square plus 70s plus 600 plus of S square plus 10s minus S square minus 60s divided by S into A square plus 70s plus 600. Correct? So this is what you are having. So now what is this now? So this is, you will end up with, so now this S square will go with this S square, and this is now, this is 70, this is 80, oh sorry, this is actually 1.2 times, this is 1.2 times. So now it is, what is 1.2 of this? So this is now actually 1.2, and this is, how much is 16 to 1.2 is 72. This is actually 72. Correct? This is actually 0.2. Okay, let me just redo it. Okay, because I forgot to multiply this by 0.2. When you multiply this by 0.2, this is now 0.2. So now, okay, let me just redo this, rewrite that. Is it not S square plus 70s plus 600 plus 0.2 S square plus, of course, 0.2 into 10 is 2s minus 1.2 S square minus 72s divided by s into A square plus 70s plus 600. Done. So this is now what you have, this is 0.2 S square, this is 1.2 S square. Now, so this plus this is actually minus 1 S square, so this will go with this, and you have this as 70, and this is 70 plus 2 72, and here it is minus 72. This will also go with this, and you have only 600 left out. So what do you have? You have CFS is equal to, CFS is equal to what? 600 divided by S into S square plus 70s plus 600. But you can see now this is 1 over S. So what is this actually 1 over S? 1 over S is actually RFS. So now I can just take out this 1 over S and replace it by RFS here. RFS here. So now, so what is CFS by RFS? CFS by RFS is now equal to 600 by S square plus 70s plus 600. This is my closed loop transformation. So what was asked is, for this, for a system having this as the time response for a unit step input, we are asked to find what is CFS by RFS. That is coming out to be 600 by S square plus 70s plus 600. Now this is equated to omega n square by S square plus 2 zeta omega ns plus omega n square, which is nothing but the standard second order transformation, closed loop transformation. So we are asked to find what is omega n and zeta. So equating the denominator of both the equations, so omega n is actually under root of 600, under root of 600. So now we have two, coefficient of s is 2 zeta omega n is equal to 70. So I can find what is this zeta, which is nothing but 70 divided by 2 into root of 600. Suppose if you find out what is this value, it is 70 divided by 2 into root of Where is root? Okay, this is root of 600. So this happens to be it is 1.428. So this particular system, so root of 600 is that into 7. Okay, this is the value of zeta. So omega n is, so the root of 600 is 94.49 radian per second, whereas zeta is 1.428. So these are the values of omega n and zeta. So that's what was the question. This was the question. We're asked to find the undamped natural frequency and damping ratio. Let us proceed. In this problem, there is a unity feedback system having GFS is equal to K by S into S plus. So let us consider these parameters. So what I have now is GFS is given by K by S into S plus 10. K into S plus 10. We are asked to find the value of K. Value of K is how much? If the damping ratio happens to be 0.5. For that value of K, what is ds, Tp, and we are asked to find what is Np also. This is what is relevant. Let me just go here. This is a system having unity feedback. So this is your GFS, and this is having unity feedback. You can see this is minus. This is RFS. This is CFS. We are asked to find the value of K such that zeta is 0.5. Zeta is 0.5. So now let us find what is CFS by RFS. Of course, it is for a RFT of unit step input. So we know that this is given by K by S into S plus 10 plus K. Of course, this is obtained from GFS by 1 plus GFS into HFS, where HFS is 1. Upon solving, you will get this as your expression. Fine. Now let me write what is CFS by RFS is now given by K by A square plus 10S plus K. We are asked to find the value of, okay, now this can be equated to standard form of omega n squared by A square plus 2 zeta omega ns plus omega n square. So from which we can write omega n square is K, so omega n is root of K, so, and we can also write 2 zeta omega n is nothing but 10. We are asked to find, okay, what is zeta is equal to 10 by 2 into omega n. So the question is, we are asked to find the value of K with zeta is equal to 0.5. So can I now write this as 0.5 is equal to 10 by 2 into root of K. So solve this to get the value of K. So what is K is equal to now? So K is equal to, what I'll do is 0.5 alpha equals to the parenthesis 10 divided by 2 into under root of alpha a close shift cal. I get the value of K as 100. So K value is 100. Because you can solve for this K value, or you can just feed it as it is into the equation onto your calculator and get the value of K. So this is the value of k for a zeta of 0.5. With this value of k, you're asked to find settling time, peak overshoot, and the peak time. So we know the expression for MP is nothing but e power minus zeta pi by 1 minus zeta square. So I can write it as, okay, now it is inverse minus of it is 0.5 into pi divided by okay, under root of, it is under root of, again, 1 minus 0.5 whole square, close, shift. I think it's not shift cal, let me just do equals. So I'm getting it as MP is equal to 0.163, which is nothing but 16.3%. This is the value of MP. We actually substituted the value of zeta as 0.5 and then proceeded. What is TP is nothing but pi by omega d, which is nothing but pi by omega n into under root of 1 minus zeta square. So it is now it is pi by omega is, so omega, because now this is omega n is root of 100, which is nothing but 10 radian per second, divided by, okay, pi by 10 into the parenthesis and the root of parenthesis 1 minus 0.5 whole square, close. This is the value. So it is coming out to be 0.362 second. This is my peak time, pi by omega d. Then we are asked to find the settling time. Let me know what is the percentage. It is given as 5% settling time. So we know that for 5% settling time, Ts for 5% is 3 by zeta omega n. 3 by zeta omega n. So 3 by zeta omega n, I have 3 divided by zeta is 0.5 into omega n happens to be 10. So this happens to be 0.6 second. So in this problem, we were asked to find the value of k so that zeta is 0.5. So what we did was we actually obtained the transfer function for this block diagram and equated this to the standard second order transfer function and found, okay, the quotient of s is 10 here and here it is 2 zeta omega. Then we equated those two coefficients and then find the relationship between zeta and this value. So for a value of zeta is equal to 0.5, we got the value of k as 100. So with this k as 100, we are trying to find what is the maximum overshoot, peak time and the settling time. We know that for this system, okay, let me just for reference, if I write this as my R of t, this is with respect to time. If I write the response of the system, it goes like this. So this is how it is going. So now this time is 0.36 second and this overshoot is 16.3% overshoot from 1 and settling time 5% is somewhere around 0.6 second. So that's what is the response of the system for a unit step input. That's fine. So let us move on to the next problem. The next problem says okay, now there is a system with a GFS given as so and so. Okay, let me just write that. So this is what I have is there is a plant with GFS is equal to 2 into s plus 6 by s into s plus 3. We are asked to find what is CFS by RFS. I'm just listing it out. We are asked to find what is CFT. We are asked to find what is CFT, and then we are asked to find for CFT for a unit step input, that is R of t is equal to U of t. Then we are asked to find LP, TP, and 2% settling time. 2% settling time. This is the task that is given. So I have this as my GFS. With this as your GFS, so CFS by RFS is, of course, HFS is 1. It's a unity feedback. It is nothing but GFS by 1 plus GFS into HFS, because it's a negative feedback system. So now this equation reduces to 2 into s plus 6 divided by so now it is s into s plus 3 plus 2 into s plus 6 is the equation. So then this becomes 2 into s plus 6, and in the denominator it will be s square plus 3s plus 2s plus 8, correct? 2s plus 12, so 2s plus 12. So this comes out to be 2 into s plus 6 divided by s square plus 3s, 5s plus 12. This is my CFS by RFS, correct? This is my okay. Now this is the system what we have. Now we are asked to find what is that we are asked to find. We are asked to find what is CFT for a step in. CFT for a step input. Now let us try to, okay, whenever you are equating the transfer function, so no matter what is the component that you have in the numerator, you have a look at the denominator, because the order of the system, the poles is decided by the denominator of the system. So you equate this to s square plus 2 zeta omega ns plus omega n square equal to 0. So from which you know that now omega n is equal to under root of 12, 2 zeta omega n is equal to 2 zeta omega n is equal to 5. So that zeta becomes 5 by 2 into root 12. So how much is 5 divided by 2 into root of 2 into root of 12. So this comes out to be 0.721. So the value of zeta is 0.721, which is between 0 and 1. No matter whatever you have on the numerator, the system response is majorly will be decided by the poles of the system. Zeros will not contribute to the response of the system. So now you have this as your zeta value, and we know the value of omega n. So how much is omega n? This is root of 12. Root of 12 is omega n is 3.46 radian per second. Let me also find what is omega d. It's nothing but omega n root of 1 minus zeta square. So this into under root of 1 minus 0.72721 square, close. It is not 2.4. This is 2.4 radian per second. This is omega d. So now for this second order system, we know that for a second order system, of course, the order of the system is this. For a second order system, C of t is given by 1 minus e power minus zeta omega nt by under root of 1 minus zeta square sine omega dt plus theta. This is my expression for C of t for a unit step input for a second order system. So now I know all these values. Now it is 1 minus e power minus zeta is 0.721 and omega n is how much? 3.46 t divided by 1 minus 0.7721 whole square multiplied by sine omega d is 2.4 t plus theta. We know that theta is nothing but cos inverse of theta. So that's what we learned in the previous. It is cos inverse of zeta. So what is cos inverse of zeta? That is 0.721. It is this much angle, which is 43.86 degree. So now it is into pi divided by 180. So this happens to be 0.765 radian. So now what is this equation? It's actually 0.765 radian. The equation now is 1 minus e power minus how much is 0.721 into 3.46. It's actually 2.49 t divided by how much is this? Okay, it is the root of 1 minus 0.721 square plus it's actually 0.69 into sine 2.4t plus 0.765. This is my CFT. Because it is sine omega dt plus theta 1 minus, this is 1 minus e power minus zeta omega nt by 1 minus zeta square. So these are the values of, this is 1 minus e power minus 1. So this is the time response of the system having this as your GFS for a unit step input. And then you're asked to find what is the value of MP, TP and TS. So we know the expression for MP, TP, TS. So for MP it is e power minus zeta pi by 1 minus zeta square, and since zeta is 0.721 you can write, so it is exponential minus, what is this, 0.721 into pi, sorry, it is power minus 0.721 into this pi, zeta pi divided by, open the parenthesis and the root of open the parenthesis 1 minus 0.721 whole square close equals, so you can see now it is 0.0380, which happens to be 3.8% is the value of overshoot. It is 3.8%. What is TP? It is pi by omega d. So omega d we already know. Omega d is 2.4. It is pi by 2.4 second. It is pi by 2.4, which is nothing but 1.3 second. 1.3 second. How about the TS? TS is for 2% you have it as 4 by zeta omega. It is 4 divided by zeta is 0.721 into omega n is 3.46. So So it is now 1.6 second. 1.6. So now these are the values of overshoot 3.8%. So there is a TP of 1.3 second. So there is a settling time of 1.6 seconds. This is how we can able to solve the problem. So that's how we are supposed to handle these problems. And let us see what is. Okay, we'll see other problems in the next video. So please try to understand. Please try to know the equations and then try to relate it to the standard equation, standard form of your second order transfer function, and then try to find the value of zeta and omega so that you can easily find out the required parameters. Thank you.